What's up, Algebra? Today we are going to start on Chapter 8. Chapter 8 is where it starts to get really interesting as far as diving really deep into algebra. This, I remember, was a big part of Algebra 2. Okay, so this is like introductory to Algebra 2 when I took it anyway. So just expect that this is stuff that's not going to go away. So it's very important that you understand these concepts for all of Chapter 8, not just this one, 8.1. Make sure you really grasp these things because they're going to be really important once you get into high school and you get into Algebra 2 and things like that. So yeah, just keep that in mind as we go forward through Chapter 8. Ask questions if you need to. And yeah, that's it. Let's go ahead and get started. So today we're starting out with adding and subtracting polynomials and I think monomials as well, maybe a little bit. Really polynomials, okay? So just a few things that we need to know before we get into actually adding those. A monomial is just something that is basically it has a whole number exponent. Okay, so some examples of those are all of these 18, z, all of these, right? They've all got whole number exponents. Okay, just a quick note, some of them may not seem like they have a whole number exponent. Just remember that is 18, okay, which is actually the same as 18x to the 0. Okay, 0 is a whole number and it's an exponent here. The reason we say that is because we always want to put those exponents onto a variable, okay? So that's why it's not just 18 to the 0. This is, 18 to the first power. This is 18 times x to the 0, which anything to the 0 power is just 1, so that would be 18 times 1, which is just 18. So you can see that that one is an example of a monomial. All right, and then z is another one that seems like maybe it isn't, okay? But again, that's just z to the first power. So again, whole number exponent, so we're good on that, okay? The next thing that we need is the degree of a monomial, and that is the sum of the exponents of its variables, all right? So if we look at some of these examples here in problem 1 down here, okay, it asks the degree for each monomial. All right, so the first one they give us is 5x. Okay, the degree there is going to be 1 because our exponent is just 1. All right, if we look at B, we've got 6x to the third and then y squared. All right, that one's going to be degree 5 because we have two exponents here, 3 and 2. Add those together, 3 plus 2 equals 5. So that is our degree for B. And then lastly, the degree for C, which is 4, would be 0. And that's because, as we showed earlier, 4 is the same thing as 4x to the 0. And then the degree of that 0 is just 0. Okay. So, yeah, that's pretty much it for problem 1. When we look at degrees, I want you to go ahead and try out B and C on your own. Actually, you know what? A, B, and C. So go ahead and do all three of them. And then after that, we will go ahead and move on. All right, so problem 2 gets into the adding and subtracting of monomials. Okay, and this one we can, we can do addition and subtraction whenever we have like terms. All right, so if we look at problem 2a, it gives us 3x squared plus 5x squared. All right, and in order to do that, all we got to do is combine our like terms. X squared gives us like terms here, so we just have 8x squared. All right, that's a pretty good example there. Now, an example of one that seems like maybe it would be, but isn't, well, there's a few examples, right? So we have 4x plus 4x squared, okay? These are not like terms, okay? And the reason is this one has a degree of 1, whereas this one over here has that degree of 2. Okay, so you cannot combine. All right, so don't get confused on that. Another example of one that seems like maybe it is, probably a little bit less so, would be 4x squared plus 4y squared. Okay, those seem like, because they have the same degree, you can combine them, but they have different variables, so you can't do those either. All right, they've got to be the exact same as far as this piece right here. All right, that's what we're looking for when we do these. Go ahead and try out Got It problem 2 right here, and then we will go ahead and move on again. All right, so now we're getting into the good stuff. These are polynomials. Okay, a polynomial is basically just a bunch of monomials that are added or subtracted, really just added together, right? So the example that they give right here is pretty good. We have 3x to the 4th, 5x squared, negative 7x, and 1 all added together. All right, so when you do that, we get 3x to the 4th plus 5x squared minus 7x plus 1. All right, and this is the stuff that's going to be, you're going to see quite a bit, especially in Algebra 2. You'll work with big polynomials like this. All right. This form that they have right here is called standard form. Okay, standard form is basically when we have it where the degrees, sorry, didn't mean to use the highlighter, the degrees are increasing from left to right. Okay, so I guess this one would be 1 and that one would be 0. Okay, so you can see that those decrease as you move from left to right. That's standard form of a polynomial. All right, so yeah, that's pretty much how that one works, and we'll just go ahead and move into problem 3 now. All right, so it says to write each polynomial in standard form. So as we look at A, you'll notice that the main problem here, or the only problem really, is that it's not written in the proper form for the degrees. Okay, so we need to go ahead and fix that. So we've got 3x plus 4x squared. All right, and all we have to do here is just flip them around. So now we have 4x squared plus 3x, and now we're in standard form. Okay. With problem B, again, same thing. It's not in standard form. We have 4x minus 1 plus 5x cubed plus 7x. All right. Now, I'm going to start by writing this in order from least to greatest of degrees. So that's going to give us 5x cubed plus 7x plus 4x minus 1. Now you'll notice we have two like terms here, right? Because these are both x to the first. Okay, so we can combine those. So when we do that, we're going to have 5x to the third plus 11x minus 1. And now we are into standard form. Okay. Just a little side note, guys. These are all standard form that we're talking about so far. Eventually, we are going to get into other forms. That'll be a little bit later on, though. It won't be in this lesson. So just to put that into your mind, I guess. All right. Go ahead and try out Got It problem 3A, and then we will move on again after you've done that. All right, so the last bits of this are adding and subtracting polynomials. They give us a word problem here, but I don't really want to focus on the word problem aspect of it right now. I just want to work with the numbers themselves, just so that we can get comfortable with them. Okay, so, and I'm not even looking at what the word problems mean or anything, right? So the first thing that I see is this campgrounds part, and then the second thing is that backcountry part. Okay, now to do this, whenever we're adding polynomials, all we got to do is combine like terms, right? So it's real simple, nothing too difficult here. So I'm going to go ahead and set this up as negative 7.1x squared minus 180x plus 5,800. And then it's got 21x squared minus 140x plus 1900. All right. Now to do this, all we got to do, like I said, is combine like terms. So if we combine negative 7.1x squared and 21x squared, we're going to get 13.9x squared. All right, and these two, that will give us negative 320x. And then lastly, we have 5,800 plus 1,900, and that's going to give us 7,700. All right, and that's all you have to do in order to add polynomials. All right, so not really too difficult, but it's a good one to really know how to do as we get into this sort of stuff. So go ahead and try out Got It Problem 4 on your own. And then after we do that, we'll go to the last thing, which is going to be subtracting polynomials. All right, so subtracting polynomials here on problem 5. I kind of like this one just because we've got some things that don't go perfectly together. And you'll see what I mean as far as talking about like terms and things. So this is kind of a cool example to see just because we get our first look at this. All right, so I'm actually, you can look at method 1 if you want, or you can look at method 2. It doesn't matter to me. I'm just going to write it all out, and then we'll kind of go from there. All right, so basically what I'm going to do, I'm not going to do it quite the same way that they do it for either of these two. All right, I'm just going to go over here, and I'm going to pick out the terms that I see I have. Okay, so first thing I see is I've got x to the third on both of them. Then I'm going to look at the x squared, which shows up right here and right here. And then I'm going to look at x, and there's only one right here. There's not one in the other one. And then the last one I've got is just this minus 12. All right, so now that I've done that, I'm just going to go ahead and combine all of those. So I've got x to the third minus, okay, don't forget this subtraction sign, that's very important, minus 7x to the third. All right, so that's going to give us negative 6x to the third there. Okay, next I'm going to look at, we had red, we've got these two, and again, that is minus our 5x squared. So we have negative 3x squared minus 5x squared. That should give us negative 8x squared. All right, then I've got this one, okay, plus 5x, and there was nothing on the other one. That's why we didn't do anything with it. And then lastly, we have this one here, our negative 12. There's nothing in the one on the left. But again, don't forget, we have this subtraction sign. So we're going to do minus negative 12, which is just going to be plus a positive 12. All right, so there's all of our parts to this. Okay, I'm going to rewrite it as well, just to be negative 6x to the third minus 8x squared plus 5x plus 12. And that is it for that problem. Okay, so like I said, you get a different look at it. And if you want to look into both of these methods, feel free to pause the video right now and do that. But again, it's not required. I personally prefer to do it this way just because I think visually I just like it better, I guess. That's really the only reason. So, but yeah, all of these methods will all work. Okay, the last thing I need you guys to do is go ahead and look at Got It Problem 5 right here. Once you've done that and you've completed it, you're good to go on this video. And then we will get back together as a class, and that'll be it. So I will see you there.